Hi all, dear students. In the previous video or class, we learned the electrochemical theory of corrosion, the definition of corrosion, the meaning of the corrosion, and the various reactions, that is oxidation reactions and reduction reactions with respect to the iron also. We studied. Let us continue the same module 2 corrosion. Today, in this class, I'm going to explain you the factors affecting the rate of corrosion. There are various factors which affect the corrosion rate. Some of the factors may enhances the rate of reaction. Some factors decreases the rate of reaction or rate of a corrosion. Like this, a lot of factors we can see, but here we have very few factors, like 4 factors we have here. Let us go to the first factor, ratio of anode to the cathodic area. What is this anodic area and the previous class, that is during the explanation of electrochemical theory, I explained the meaning of the area. The 2 areas are formed during the corrosion, that is anodic area and the cathodic area. Here, the ratio of these two will be the main factor, key factor, which affect the rate of a corrosion. The rate of a corrosion X is directly proportional to the ratio of area of anode to the area of a cathode. That is, it is mathematically represented as X equals area of a anode divided by area of a cathode. Here, X stands for the rate of corrosion. Higher the value of this X, that is rate of a corrosion, greater is the rate. That means here, when an anode is small and a cathode is large, all the electrons are liberated at anode and are consumed at the cathode. That means we know that at the anode region, oxidation occurs, which means electrons are released. The released electrons will occupy or move towards the cathode. That means here they are consumed at the cathode. This further intensifies anodic reaction, leading to increase in overall rate of corrosion. What happens? All the electrons which are released at the anodic area will move and consumed at the cathode, so that the further reaction which occurs at the anode increases. This leading to the rate of corrosion, overall rate of corrosion increases. For example, in the coating of a tin on the iron, both are metals, tin and iron, both are transition metal. So here tin is cathodic to the iron. If some part of the iron is not covered, it results in a smaller anodic area and a larger cathodic area. That is, tin becomes a larger area and iron becomes smaller area. In this case, more intense corrosion is observed at a smaller anodic area, that is at the iron zone. Wherever the iron is there in the combined form of this tin and iron, that iron part becomes smaller and anodic area and suffers from the corrosion, whereas the cathodic area, that is a tin, becomes safe, that is it protected from the corrosion. This is what the well-known example, tin on the iron. Let us go to the second factor here, nature of the metal. What kind of metal we have which is under study of corrosion rate? That is also a main factor. Metals with higher electrode potential do not corrode easily. So we have some of the potential values for every electrode metals, that is called electrode potential values, E0 values. If that value is high for the metal, such metal do not corrode easily. That is, they are protected. For example, platinum metal, silver metal, gold metal, they are all having higher electrode potential values. They do not easily corrode. They are noble metals like gold, platinum, silver, etc. Whereas metals with lower electrode potential values readily undergo corrosion. For example, metals like a zinc, we have magnesium, we have aluminum. They undergo rapid corrosion because of the lower electrode potential values. When two dissimilar metals are in contact with each other, higher difference in electrode potential of two metals increases the rate of corrosion. So here, whenever the two dissimilar metals, tin and iron, copper and iron, when they are in contact with each other, if the difference of the electrode potential values is high, then rate of corrosion also increases. Example, the potential difference between the iron and copper is 0.78, which is more than the between iron and tin. So for the two metals like iron and tin, its value is 0.03, and between the iron and the copper, it is 0.78. Here, this means iron corrodes faster when it comes in contact with the copper, because 0.28 value is more than that with the tin. It's 0.3, less value. That means if the difference between the values is high, then rate of corrosion also increases. That we can clearly see in this example. Position of the metal or alloy in the galvanic series also decides the rate of corrosion. You know, the galvanic series. The galvanic series contains various metals in increasing order or decreasing order of their electrode potential values. Here, the position of the metal, where it is present, whether it is at the bottom of the galvanic series or top of the galvanic series or middle, this position also a matter which decides the rate of a corrosion. The metal top in the series is more acidic, anodic, and undergoes corrosion faster than the metal below it. That means whatever the metal which is present at the top of the galvanic series, they undergo rapid corrosion. For example, iron, aluminium, copper, etc. So they are present at the topper position of this galvanic series. Hence, they undergo easily the corrosion. Next, third one, nature of the corrosion product. Almost all the corrosion products are in the form of oxides. See, in a moist atmosphere, almost all metal gets covered with a thin surface film of metal oxide as the corrosion product. This is metal oxide. For example, iron gets converted into iron oxide. Copper gets converted into copper oxide. That means almost all the metals after the corrosion, they become oxides. The corrosion product formed like metal oxide may act as a protective film if it is a stable, insoluble, and non-porous. If it acts as a protective film, it prevents the further corrosion by acting as barrier between metal surface and the corrosion medium. That is a wet medium. So between the corrosion medium and the metal surface, the oxides forms can act as a barrier if it is a porous, insoluble, and stable. On the other side, if the corrosion products are unstable, porous, and soluble, then they enhances the rate of corrosion, because there will be no barrier between the metal surface and the corrosion medium. Metals like aluminium, chromium, titanium, etc. are highly passive, as their corrosion products are protective films on the metal surface, preventing further corrosion. And metals such as iron, zinc, magnesium, and do not form any protective film and are highly susceptible for the corrosion or continuous corrosion when exposed to the oxidizing environment. Fourth one, for the last factor, nature of the medium or the nature of environment. pH of the medium, corrosion medium. The rate of a corrosion increases with a decrease in the pH of the medium. Why? Because acidic media are generally more corrosion than the alkaline or neutral media. This is due to the evolution of hydrogen at the cathode. And example, when the pH is less than 4, the rate of a corrosion increases due to the higher concentration of hydrogen ions. And when the pH is more than 10, then rate of a corrosion decreases due to the formation of an insoluble metal hydroxide on the surface of a metal. Next, we have the second and the nature of the medium, conductivity. The rate of a corrosion increases with the increase in the conductance of the medium. As the conductance of the medium increases, ions can move easily through the medium. And therefore, this decreases the polarization potential, and due to this, rate of corrosion increases. For example, the metal immersed in a seawater that is more conducting is more corrosive than the metal immersed in a river water which is less conducting. And the last one, temperature. Generally, rate of a reaction or rate of a corrosion increases with increase in the temperature. That is common for all the chemical reactions. Most of the chemical reactions are in the same order. That is, increasing the temperature increases a chemical reaction. The same thing is applicable for the corrosion also. As the temperature increases, conductance of the ions in the medium increases, which reduces the polarization. Therefore, the rate of corrosion increases. A passive metal becomes active at higher temperature and increases the rate of corrosion. So for this, the various factors affecting the rate of corrosion completes. We'll continue in the next class.